we are given x of n as a plot. Now we are asked to find out the value of x of minus 2n plus 3. Now here we have shifting, then we have scaling, and we have time reversal. Now what is the right order to do this? First we will solve this problem under the assumption that we do not know the order in which these operations are to be done. So let's do that first. Now let's bring up the table, and in order to make the calculation easier, let's fill this table. The value of x of n at n equal to minus 6 is 1. So here we have 1. For n equal to minus 5, its value is 2. Then we can easily fill this. Just we have to look at the plot and fill this. So we'll get 6, 7. Then x of n at n equal to 1 is 6. So just fill this really fast. So let's assume that y of n is equal to x of minus 2n plus 3. So let's say we want to calculate y of 0. So y of 0 will be equal to x of minus 2 into 0 plus 3. That is x of 3. So x of 3 is 4. So that will be our y of 0. Let's calculate y of 1. That will be x of minus 2 plus 3. That is x of 1. X of 1 is 6. So we'll get the same here. Y of 2 will be x of minus 4 plus 3. That is x of minus 1. X of minus 1 is 6. Now let's calculate others. Y of 3, x of minus 3. So I'll fast forward this calculation. So it's really easy. We have to just substitute for the value of n. So here we have y of 5, which is x of minus 7. So x of minus 7, we do not have it. Its value is 0. So we can put a 0 here. So for safety, let's go ahead and calculate y of 6. That will be x of minus 9. Now let's calculate the value of y of minus 1. That will be x of 5. Now let's plot this and see. So here we have the plot of y of n. That is x of minus 2n plus 3. Now let's do the same question under the assumption that we know the order in which these operations are to be performed. If we are writing y of n equal to x of minus 2n plus 3 and we want to plot y of n without any mathematical computation, what we will do is we will take x of n, then we will shift it by 3. Now after shifting, we will get x of n plus 3. Now let's say this is equal to our v of n. Now this shift is left shift because we have x of n plus 3. That means we'll take this signal and left shift by 3. Let's do that. So this is our x of n plus 3. Now what we will do is we will scale the signal. So what we have got here is our v of n. So we will scale by 2. Now x of 2n, if you remember, we will take every second sample and we will compress the signal. We will start from 0. So there is no change here. We will take this sample. We will discard this sample. We will take this sample, but it will come here. We will do that. We will discard this sample. We will discard this sample. Take this. Now let's remove them. Now we are not done yet. We have to shrink it. That will be with respect to the origin. So we will bring it closer. Now what we have is v of 2n. Let's say this is equal to some u of n. That is our u of n. Now we will do time reversal. So we will get u of minus n. Now in order to reverse, we have to reverse it about n equal to 0. You just have to flip it. So what we see when looking in this direction should now occur in the, should be seen in the opposite direction. That means this should come here at minus 1 and all these should go to the other side. Let's do that. So we'll get this signal here. So what we have done is we did the shifting first, then scaled the signal, then reversed it. So we shifted the signal by 3 to the left because we had a plus sign here. Then we scaled it by 2, then we time reversed it. So this is the order in which we should proceed. Let's see whether we have got the same answer as before. Now this was the answer after we have done the mathematical computation. And this is done completely graphically. Now let's see a quick and dirty solution to this problem. Now it will give you the answer really quickly. I will show you the solution, but now it's up to you to find out how the solution works. Now we have this term here, that is, in the bracket you have minus 2n plus 3. Now I'll assume it to be equal to m. That means minus 2n equal to m minus 3 and n equal to minus 1 by 2 into m minus 3. So we may write it as 3 minus m by 2. Now we'll start from here. So here I'll just substitute minus 6 for m here. So this will be 3 minus 6, that is 3 plus 6 by 2, which is 9 by 2, which is 4.5. So we won't be having this in our y of n. Now let's consider this here. This will be 3 plus 5 by 2, that is 3 minus 5 by 2. So that is 8 by 2, which is 4. So this will be our y of 4. Now here it will be 3 plus 4 by 2, that is 7 by 2, which is 3.5. So we don't have this in our output. So this will be 3 plus 3 by 2, which is 6 by 2, which will be 3. So this is our y of 3. So we won't be having it. This will be our y of 2. We won't be having this one. This will be 3 minus 1 by 2. All we are doing is we are substituting 1 for the value of m. So this is 3 minus 1 by 2, that is 2 by 2, which is 1. So this will be our y of 1. We won't be having this in our output. So this here will be 3 minus 3 by 2, which will be our y of 0. We won't be having this in our output. This will be y of 3 minus 5 by 2. 3 minus 5 will be minus 1, minus 2. Minus 2 by 2, which is minus 1. So we will get y of minus 1. This we won't be having in our output. Now in this way we can quickly find out how x of minus 2n plus 3 will look like. Now it's up to you to find out why this method works.